Hello, everybody. Welcome to Learning Management System initiated by Department of Collegiate and Technical Education. Myself, I'm Dr. Prashant, working as a professor in the Government Engineering College. Awesome. Now I'm going to give a lecture on Water Supply and Treatment Engineering 18CV46, Module 3. In the Module 1, you have discussed about the sources of water and how to estimate um, the population, future population. Then you might have discussed about the different demands of water and all those things, and you might have even discussed about the design period and all those things. After studying the module 1, in the second module you have been made to understand the treatment of water and how to what are the different types of intake structures that are generally used in the water supply and treatment engineering, and what are the uses of that one and all those things. Here in the module 3, I'm going to take a module 3. In the module 3, in the session 1, um, in the session 1, I'm going to discuss about treatment of water, which is called as sedimentation, plain sedimentation. And I'm going to touch even the types of settling tanks and what are the design concepts in the plain sedimentation tank. So let us start with the plain sedimentation tank. Plain sedimentation. What is plain sedimentation? You know, water quite naturally, when there is a rainfall and the rain flows on the ground, it carries a lot of impurities in the runoff, and finally it reaches the river source or a lake. And usually the surface sources are for drinking water is either a river or a lake, depends upon the geography of that place. So water has got a lot of suspended impurities in the in it. So when the suspended impurities are more, the quality of the water also changes. So we have to get rid of the impurities or the suspended impurities from the water, and we have to make the water to crystal clear and clean so that it can be used for our domestic purposes. So most of the suspended impurities present in the water do have specific gravity greater than that of water. So suspended impurities may be made up of the soil, silt, mud, sand, etc. So most of the suspended impurities present in the water do have specific gravity greater than that of water. So when you know its specific gravity more than that of water, in still water or if the water is kept quiet for some time, these impurities will tend to settle down under gravity. Although in normal supplies they remain in suspension because of the turbulence created by the water. In the quiet water, these particles tend to settle under the force of gravity. So, hence, as soon as the turbulence is retarded by offering storage to the water, these impurities tend to settle down at the bottom of the tank. This is the principle of sedimentation. So, whatever the impurities which are present in the water, understand, if the water is kept quiet for some time because of its specific gravity, these particles tend to settle down. And that process or that principle is called sedimentation. That means allowing the water to keep quiet for some time and making the particles to settle. So this is how we are going to separate the suspended impurities which are present in the water. So for that we use a tank that's called settling tank. So the basin in which the flow of water is retarded is called the settling tank or sedimentation tank, or it's also called as sedimentation basin or clarifier. So the time for which the water is kept quiet without any turbulence is called detention time. So plain sedimentation is allowing the water to keep in calm for some time and allowing the impurities to settle is called sedimentation. This is done in a tank called settling tank or sedimentation tank. What is the purpose of settling? The purpose of settling, as I said, whenever there is a rainfall, the rain flows on the ground, what we call it as runoff. Runoff carries a lot of waste products, debris which are present on the ground. Understand? And it carries and takes it to a lake or a river. So, our main purpose is to remove the coarse dispersed the particles, to remove coagulated and flocculated impurities, to remove precipitated impurities after chemical treatment. These are the purpose of settling. See, if the particles are discrete particles and if its specific gravity is more than one, definitely they are going to settle if you keep the water quiet or without any turbulence. Understand? Sometimes the particles are so small, even if you allow for 2 or 3 hours of detention time, these particles are not going to settle. They move up and down because of the Bruneian motion. Therefore, in that particular time, what we do is we add some coagulates and make the flocks. That is why the third one is written as to remove precipitated impurities after chemical treatment. So basic purpose is to remove discrete particles or dispersed particles, to remove coagulated and flocculated impurities. See, to understand the settling, there are four types of settling which generally takes place whenever a particles are in the suspension, and if you allow the water to keep quiet for some time, the particle settles down, but it settles in four different types. The first one is called type 1 settling, second one is type 2 settling, type 3 settling, and type 4 settling. So this is very important you have to understand, because this information, whatever you are going to learn here, will be useful in the next sem also. So in the type 1, discrete particle settling, particles, that means impurities which are present in the water, will settle individually without any interaction with the neighboring particle. So every particle which settles, understand, they have got individual property, they are not going to mix up with other property. Every individual particle has its own type of settlement. So particles settle individually without any interaction with the neighboring particles, which is called as discrete particle settling or type 1 settling. In the type 2 settling, we call it as flocculent particles. See, as the name itself says, flocculation causes the particles to increase in mass. So one particle is going to adhere to the another one. Its mass increases, so it will settle at a faster rate, which is called as flocculent particle or flocculent particle settling. And another type of settling that we see is type 3 settling or hindered settling or zone settling. What is this? The mass of particles tends to settle as a unit, with individual particles remaining in the fixed position. That means one particle is going to adhere to another one, another one, another one. There will become a big mass. Understand? They are going to settle at in the settling tank. Understand? So every position is fixed with respect to each other. And in the type 4 settling, compression settling, the concentration of the particle is so high that sedimentation can only occur through compaction of the structure. In the next slide, I am going to show you the figure so that you can understand better. See here, examples of settling. And the first one is the type 1 settling, what I told in the previous slide, that is discrete settling. Particles are settling down in the water, and every particle is separate. They are not interacting. Whereas in the type 2 settling, one particle is adhering to the another one. That is called flocculent, flocking or taking place. And in the hindered settling, understand, the more flocks are there, understand, and the whole bunch is settling. For example, one, two, three, four, five. What is this one? They are settling down. Every particle remains with respect to the other particle in the same position. So as a mass, it is settling, which is called as hindered settling or type 3 settling. In the fourth settling is the zone settling. That is the compression. Because of the heavy load of the top layer, understand, bottom layer will be compressed. That is how its settling takes place, which we call it as compression settling. So in the type 1 settling, what is the information what we can gain, or what I would like to share is, in discrete settling, individual particles settle independently. So there is no interaction. Every particle has its own individuality, and it occurs when there is a relatively low solid concentration. So when the particles or the waste particles or the waste material or the suspended impurities in the water is in very small amount, this type of settlement takes place. The flocculent settling, one particle is going to adhere and that is going to settle down. Three particles on the three particles. Hindered, more number of flocks, 5, 6, 7, and whole block is going down. No particle is moving here and there. That's called hindered settling. Compression. See, when one particle comes on the another one, it put load on the another particle. So that is how the settlement takes place, which we call it as compression settling. It occurs when the particles settle by compressing the mass below. So four types of settling are there: type 1, type 2, type 3, and type 4. Here, in the discrete particle settling individual, that is how you get the clear picture. And in the flocculant settling, things will be much better than the discrete. In the hinder setting and in the compression zone, most all the particles are settled at the bottom. So discrete particle settling, flocculant, hindered, and compression. So we have discussed about what is sedimentation. Sedimentation is a process in which water is kept quiet and particles are allowed to settle down. That's called sedimentation. And coming to the settling of particles, four types of settling takes place. And that is, individual particle settling is called type 1. Flock formation and settling is called flocculent. And more number of flocks, that's hindered. And last one is the compression zone. All this happens in a sedimentation tank. So let's study what is sedimentation tank. See, as I discussed in the first slide, sedimentation is a tank wherein sedimentation process takes place. So, what are the different types of sedimentation tanks that are generally used all over the world in the treatment of water? See, sedimentation is one type of treatment of water wherein the suspended impurities are removed by using force of gravity. We are not going to add any chemicals. We're not going to add any other extra uh, material. It's only through force of gravity. So coming to the types of sedimentation tank, two types of sedimentation tank we can see: horizontal flow tank and vertical flow tank. So some tanks where the flow is flown horizontally, and in some tanks water flows from bottom to the top. That's called vertical tank or upflow tank, so called. See, in the horizontal flow tank, if you see the tank from the top side, if you see the plan of the tank, it may be rectangular, it may be circular also. Flow. Okay, we can have circular tank also, and we can have the this one flow. So in the horizontal flow tank, in the rectangular tank, we can have continuous flow type, and in the rectangular tank, we can have a batch process also called intermittent. That I will explain in the next slide. So intermittent batch process means bring the you will have a tank, fill the tank with the water, keep the water quiet for some detention time, 2 hours, 3 hours. Particles will settle down, take out the water, and fill again the tank with a new batch of water. That's called this one, the batch process. But in some places they don't fill the water in the tank. Instead of that one, they'll flow the water, or they'll allow the water to flow so slowly, so particles will get time to settle down. That type of called continuous. So horizontal flow tank may be rectangular and maybe continuous type or intermittent. And whereas the vertical flow tank, and then most of the time it's circular flow only, circular shaped tank. And in circular shape, radial flow with central field means water comes from the center and moves towards the edge. That's called radial flow with central feed. and in some places it's the peripheral feed. So the main thing you have to understand is two types: horizontal flow, vertical flow. Horizontal flow may be rectangular may be continuous flow or intermittent. Circular flow may be a radial flow with central feed or maybe a peripheral. Let us see some information about the rectangular sedimentation tanks. Rectangular, see, sedimentation tanks, settling tank, clarifier, basin, these are all the same words uh, we use for settling tank or sedimentation tank. So, rectangular basins or rectangular sedimentations are commonly found in large scale water treatment plants. So, big water treatment plants, we use rectangular basins. Why they are popular? Because they have high tolerance to shock overload and its performance can be predictable. See, water treatments are very important. Every day, every 24 hours, we have to supply the water. So, we have to maintain the treatment plant very well. So, if there are some changes in the treatment system, we have to be in a position to understand it. So, the performance has to be predicted, and cost is very important because treating of water is a costly affair. Huge amount of water has to be treated. So cost effectiveness due to lower construction cost in the rectangular tank, and maintenance cost is very less, and minimal short circuit. Because of these points, the rectangular tanks are popular. One is the high tolerance to shock overload. Its performance means its treatment performance can be predictable. It's a it's not a costly affair to build a rectangular sedimentation tank, and maintenance of the rectangle tank is also very less. It's a very simple tank and minimal short circuit. I'm showing a picture of a sedimentation tank in some water treatment plant. See, tanks are very large tanks of size 60 to 70 meter, 80 meter mm, tanks. So water is allowed to flow through this, and the water is allowed to flow through this, and the velocity is controlled, and the velocity is so slow, so small, particles get time to settle down in the tank. When the particle settles, clear water moves out of the tank. That is how we are going to remove the suspended impurities present in the water. This is another tank. Two workers are standing inside the tank, and they are cleaning the surface or maintaining this one after one operation. So this is a simple tank what you see in your home's small tank. Here it is a bigger portion. Coming to the circular sedimentation tank. Circular basins or circular sedimentations are referred as clarifiers. It's also called as clarifiers. These basins share some of the performance advantages of the rectangular basins. These basins are also is advantageous, but are generally more prone to short circuiting. I'll explain what is short circuiting and particle removal problems. So the circular sedimentation tank has also got some problems, but when you do not have much space, then these circular sedimentation tanks are useful. If the space available to the water treatment is large, then we go for rectangular tanks. Coming to the circular tanks, in the circular tanks, as I explained in the previous slide, there are two types: circular tank with radial flow. Radial flow. Try to understand. What is this? Circular flow tanks with radial flow with central feed. Water enters here. See, influent. There is a influent means water to be treated is coming, is going up and moving towards the weir. It is going, it is coming here like this, and it is moving towards the edge of the tank. That's called central tank with radial flow. Okay, and it provides with multiple ports. From it emanates out to the out of out to flow radially outwards in all directions. So water enters from the center of the tank, it move towards the edge, understand, radially in all direction. When the water is moving slowly, particles which are present in the water will try to settle down. There is a scraper arrangement blades are there. It is going to scrap it out, whatever the particles which are settled out, what we call it as settled particles, is taken out. And generally it is operated continuously, and the process continues. There is no filling the tank, keeping quiet for some time towards. We don't do like that. Understand? So the velocity is so reduced. We give particles are given a chance to settle down. This is a central inlet peripheral feed. See, it is moving the water influent center feed and moving towards the peripheral outlet. So it's a circular basin. Effluent is coming this way. Water is entering, moving in this direction, and going. The outlet is effluent is coming from this place. Influent and outside or peripheral feed. Influent is going from the left side and moving in the left and right direction. Then effluent is going. So feed is from the peripheral side. One is the central feed towards the radial direction. Another one is the peripheral. See, it's a figure of a picture of a circular sedimentation tank. See, this is giving this one center arrangement. I'll show in the next slide. See here. This is a structure made up of steel truss. It's a scrapping arrangement, and a round circle. This one is called as a feeding arrangement. Water comes from the center and moves towards radially in all direction towards the edge. So when the water is moving slowly, particles which are present in the water are moving with the water. Because of the slow velocity, it settles down. And whatever the particles which are settled down are taken out with the scraper arrangement. See, this is the figure from the top side. See, this is the what we have discussed is what is sedimentation, and different types of settling that takes place. Then we discussed about the different types of settling tanks. So horizontal settling tank and the vertical settling tank. Horizontal may be rectangular in shape, continuous flow or intermittent flow, and circular, central feed, radial flow or peripheral. See, our main is we have to design the sedimentation tank to treat the water. To design the plain sedimentation tank, you have to understand some words or some concepts here. One of the important definition of the word we have to keep it in mind while designing the sedimentation tank is called overflow velocity. It's also called as overflow rate. It's also called as surface overflow rate. It's also called as surface loading. All are same. Surface loading rate. In some books they use SOR. In some books they call it as SLR. All are the same. What is this? It is the volume of water. Surface loading rate means it is the volume of water passing per day per unit horizontal area. It is the volume of water passing through the tank per day per unit horizontal area. This is that flow velocity at which tank is designed to. So this is the flow velocity at which the tank is designed. So what is overflow? We have said it is the volume of water passing per day per unit horizontal area. So OLR, overflow rate, is equal to Q by AS, volume of water flown through per surface area, unit surface area. So Q is volume by AS is the surface area. What is Q? Q is volume by time. It is the discharge. So Q is nothing but surface area into depth. That is the volume of water per time divided by surface area. So surface area cancels, and depth by time. What is depth by time? Unit is meter per second. Nothing but velocity. So V naught. So overflow rate is nothing but it is the liquid velocity. So the liquid upflow velocity is called the overflow rate or the surface loading rate because water is flowing over the top of the tank into the weir system. It is nothing but the liquid velocity V naught. So this is very important. We have to understand. Again, I'll repeat. It's the volume of water passing per day per unit horizontal area. This is the flow velocity at which the tank is designed. So overflow rate Q by AS. After doing all these things, it comes as meter per second, nothing but velocity. The liquid velocity is called the overflow rate or the surface loading rate because water is flowing over the top of the tank into the air system. And we use another term called detention period. What is the detention period? Means we see initially we said uh, take a impure water, keep it in a bucket for some time, for 1 hour or 2 hour. So after 2 hours, all the particles will settle down. So whatever the time for which you have kept the water without any disturbance, that's called detention time. So theoretically, it is the time for which the water is detained in the tank. So mathematically, T is equal to V by Q, volume of the tank by rate of flow. Volume is meter cube. This is meter cube per second. So meter cancels. So detention time is second, hour, day. This is another thing you have to keep it in mind. Another definition or another word you have to keep in mind for designing is flow through period. What is this? It is the actual time of travel of flow from inlet to the outlet of the system. See a rectangular tank, you have an inlet and an outlet. So time taken by the water to move from inlet to the outlet is called flow through period. It is always less than the detention time due to short circuiting. Okay, so that's due to short circuiting. I'll explain the short circuiting after some time. And another one is displacement efficiency. What is displacement efficiency? It is the ratio of flow through period to the detention period. See, detention period is the theoretical time which water is detained in the tank. Flow through period is the time of travel, actual travel. What if the particle enters the inlet and whatever the time it takes to reach the outlet, that's called flow through period. But it should be equal to the detention period that generally not takes place in the moving water. Sometimes it may be lesser than that due to the, or it may be more than that due to the short circuiting. And displacement efficiency, it is the ratio of flow through period to the detention period. It is generally varies between 0.25 to. So this is for the session one of module three. And so these are the references I've used. You can use the book SK Guard by Kanna Publishers, Water Supply Engineering. And this is created by Dr. Prashant from Government Engineering College, Assam. Thank you.